Okay, so we are going to be reviewing the fifth, I think. We will be reviewing the essential algebra. This is essential. You have to know. You have to know the equation of a line. Does anybody remember what slope-intercept is? Oh, that's the one you learned from the beginning. Very first one. Okay, y equals mx plus c. Okay, I can enter that into my calculator, which is really nice. The slope is the coefficient, the number in front of x. Oh, I don't know if I like that. So m is equal to the slope. And I don't know about my classes, but I know that some of you wanted to make it include the x, but you can't include the x. It's just the coefficient. It's just a number. And the way I talk about slope with my linear algebra students, because they just have a really hard time, you know, we all know it's rise over run. It's like saying, it's 80 degrees outside, or what's it in here? We all know what that means, 76 degrees in here. We know what that means because we're so used to doing it. You don't walk around and say, well, the slope of that hill is. You don't do that. So it's not as common knowledge to you, but it really is, because how many of you snow ski? No, nobody skis? Raise your hand if you ski. Well, it didn't say you had to go well. Okay, so we ski. And back when I was your age, we used to say we're going to go hit the slopes. That's an old word, huh? Okay, it describes it well. Slope is just a number that describes how steep the hill is. So if you have an 18% grade, that's a very steep hill. If you find the angle using trigonometry, you'll find out it's not a very big angle. So I'm trying to put in a garage at my house, and I think the slope of the driveway was over 10%. And it's too big, so they have to do some extra work and actually lower my garage, so that's my grade is only 7%. And that's huge. This is a construction guy. He's working with slope all the time. But I understood what he was talking about, but a lot of people wouldn't. So I knew what he was meant there. And then what I do is M actually stands for monter in French, which means to climb. Any French students in here? And B is for the base, base. But I like to tell my algebra students it's the beginning point when you start to graph. And it's on the y-axis. Okay, so we start in first year algebra with y equals mx plus p. There's nothing special about that form. Matter of fact, in calculus, I'm not going to use that form. Unless I want to find the slope of a line, and I'm given some sort of equation. Calculus, I'm going to use the point slope form. Does anybody know that one? Yep, y minus y1 equals the slope x minus x1. And that just comes from the slope formula. If you didn't know that, slope formula is m is equal to y minus y1 over x minus x1. And because that's a proportion, I can multiply the means and multiply the extremes. Sorry, m and the x minus 1 are the extremes. The 1 and y minus 1 are the means. And I get that equation. So I like this much better. And on the exam, that's all you need. You do not need to simplify anything. These are the unknowns, and you're going to be writing equations of lines many times. You need 100% accuracy on this. It's huge on the exam. Go look at the exams, and they'll say, write the equation of the line many times over. If you can't get a 5 if you can't do that. I don't think you can get a 4. Now, I prefer the point slope. Slope-intercept, sometimes if it's easy, I'll use slope-intercept. Most of the time it's not. And then standard form, how about standard form? That's what we use to solve systems of equations. AX plus BY is equal to C, which is the form on that first question on that worksheet. It's in standard form. Remember, it was X plus Y is equal to 2, right? And to find the slope, I'm going to have to change the slope-intercept form. So I'm going to solve for y. If I wanted to graph it, think of it this way. If I wanted to graph it on my graphing calculator, unless you have the new Inspire, The new Inspire, you can type it in as written. But on your calculators, the 83s, you have to solve for y. So we're going to subtract x from both sides. And so y is equal to, I prefer to keep my x's first, but you know what? Even my linear algebra kids don't. But it's minus x plus 2. I said that's fine as long as you know where the slope is. What's the slope here? Negative 1. And you would begin at 2 on the y-axis. So if you just can think of slope as just a measurement, that's all it is. And we just don't use it that much. Now, I was trying to get, I have my infinite cloner. That's not a good thing right now. Turn that off. And I just put a little graph here. You don't have it, but to find x and y intercepts. So I'm going to draw a line, and this is a new program for me, so I'm not always familiar with how to operate this. And there's my line. And the x-intercepts are where the line crosses the x-axis. So I know I have numbers here, but what would that be? Well, let's do the y-intercept. What's the x-coordinate on the y-intercept? 0, and that's b. And this would be some number. I don't care what it is right now. It's a, comma, 0. So when you have intercepts, you always have one of the numbers are going to be 0. So when you're going to get into word problems and they're going to say something about intercepts, you need to realize that one of the ordered pairs is 0. Okay, remember that pretty much? That's linear algebra. And then we come down here to a little bit of higher algebra and a lot of pre-calc. Do you remember what e to the x looks like? It's an exponential. Yeah, it does this kind of thing. So I'm going to draw one in here. And actually, I do know where that goes. Now, we like e. By the way, what is e? Approximately. Good. We're not going to use base 2. We're not going to do 2 to the x or 3 to the x. We're going to do e to the x. But they all look the same. And when the y value is, when x value is 0, then y is equal to e to the 0, which is 1. And if we do chapter 1, we'll be reviewing all those properties of logarithms, which won't hurt us. So that is my x-intercept, y-intercept, 0, 1. What's true about the x-intercepts? Are there any? So there are no x-intercepts. I leave myself a lot of room. So for e to the x, what's my domain? Now remember what domain is. Okay, so vocabulary, maybe we should create a vocabulary list because we have to know what the words. All the possible x values, if you're working with x's. If we're working with t, then it's all the possible t values. So it's all the possible inputs. I don't want to be specific because when you get into the exam, if you turn the page over and all those are real problems, those came right off the exam last year's. So you're going to see that things are not always going to be in terms of x's. So these are the inputs. What's true about my x values? Yes, infinity. I could write it this way, is an element of the reals. And I actually should have an extra little line there, but I'm kind of lazy about it. Or you could go negative infinity to infinity. Do you remember this notation with the parentheses? Can you see that okay? Otherwise, come up front. Because it's pretty big. But we'll save it. What about the range? What's true about the y values? Bigger than 0, right? So you can say y is bigger than 0 or 0 to infinity. Now, how are e to the x and log of x related? Natural log. I always say log, though, because we always do natural log. Pardon? They're inverse functions. Do you remember what happens to inverse functions? They switch the domain and the range and reflect over y equals x. Okay, so I'm going to change my color again. And so now that was at 0, 1. And this will be at 1, 0. supposed to have a better reflection than that. Maybe I can fix it. I can try. There. That's better. Now be careful with your calculator. It looks like the log function actually touches the y-axis. Now the 83s, 84s are better, or the 84s are better. 83s, it actually kind of connects the axis, but it doesn't ever connect. Because if you look at your e to the x, your range is never 0. So when I do this, so for the log function, the domain, what's true about the domain? What are the x values? They're never going to be touching that axis. So x is what? Greater than 0, or 0 to infinity. So when you think of the log problem we gave you, and the original one was way more complicated. I made it easier. It's just a translation 2 units. And then what's the range? All the real numbers. I kind of like this notation. It doesn't matter as long as we communicate. And there's certain notations that everybody understands. Now we may make up some notations for ourselves, but you can't use them on the exam. Right. What do I have? Let's see if I have it here. See, that's the problem. I could try this graph instead. There. Where is it? Oh, I know where it is. Nope. That's pretty big. I still don't like that one either. So I'm going to get rid of that. I wonder what I just cut. Well, we'll ignore it for now. Okay, so we're going to ignore the numbers here. Or I could just actually draw another graph. Maybe I should just do that. It's hard to find good graphs. Now, you are going to want to learn the sine graph. Because when we do the trig, this is how you're going to remember what the sine of 0 is, and the sine of 90, etc. You all know what the sine graph looks like. What's the sine of 0? Starts at the origin, right? And the period is 2 pi. So I could actually do this, slide this one over. Now, do you remember odd and even? Not odd or even. It's odd because I could have just taken this and rotated it and brought it over here. It's a 180-degree rotation, otherwise it's 2 other kinds of translations. But I don't want that. And it doesn't really matter if I do that. It's still the same. Okay, so we know it's 2 pi. So this is 0. This is 2 pi. And these are the quadrants. Now, we're going to be in radians. I don't like degrees particularly, but this is pi. That's halfway. And this point in between here, this maximum is halfway. So it's where? Pi over 2. If you think of your unit circle, that's 90 degrees. But the unit circle is much harder to deal with. So I don't deal with it. I deal with the sine graph. And where's this? Halfway between pi and 2 pi is 3 pi over 2. That you have to know. You have to know the sine of pi over 2. You have to know the sine of pi. I will tell you all year, draw the sine graph on your test copy and then just look at it because that's all you want to do. If you go to the unit circle, it's a lot harder because you have to remember that the sine is the y value and the cosine is the x. That's hard. This is much easier. Okay, what's my domain here? What are my x's? Okay, x belongs to the reals. And what's true with the range? Yes, I didn't put it in here, but that's 1. Here's negative 1. So the range is y is between 1 and negative 1. You can write it this way. You can use the brackets. If you're from Europe, they do the brackets backwards. They do them this way, which is hard for me to get used to. Yes. It's actually 1. So if I wanted to find the sine of pi over 2, it's 1. Remember, this is the angle. This is the trig ratio. Question, ask. If you have a question, somebody else does. Guaranteed. If you're in Europe, this is the European way of doing it. Well, and the reason being is because if I want to look at the ordered pair, -1, 1, how do I know it's that, or if I really want the interval from -1 to 1? So if you do this, you know it's the interval. That's probably why they do it that way, which is kind of nice, but we don't, unless you're taking the IB exam. I don't know how that would work. Okay, do you remember the sine function now? How about the cosine function? I'll just draw it. Oh. Okay, do you remember what the cosine function looks like? It's just like the sine function. It's exactly the same as the sine, except it's shifted. Question? Yes. Oh, I forgot the intercepts. What are the x-intercepts? Oh, how would you write them all? That's always tricky. You're not going to have to know that. I thought it was a different color, but okay. Where is the x-intercepts? X-intercepts are x equals 0. Sorry, I forgot to answer that question. Pi over pi. Where's the next one? 2 pi, 3 pi, 4 pi. So you would say n pi. They're going to give you a closed domain. They're going to go between 0 and pi or 0 and 2 pi. It's a rare day that they're going to really force you to use that. So that's good. That's, in that sense, calculus is much easier than pre-calc. Calculus is. Because the pre-calc will make you go to n pi. We're not. They're going to give you a domain, so you're not going to have to worry about it. Okay, let's draw the cosine function. And there it is. Where's this? 2 pi. Halfway is pi. Halfway to get the first intercept is pi over 2. And this is 3 pi over 2. And I could go to the left of that too, because it's just the same thing. So what is the cosine of pi? It's, look at the picture. Cosine of pi is -1. That's how I remember them. Common mistake is everybody gets the cosine of 0 wrong. Cosine of 0 is not 0. That's the sine function. This is 1. So where are the x-intercepts? Okay, this will be a little trickier. It's pi over 2, 3 pi over 2. Where's the next one? Where's the next intercept? 5 pi over 2, isn't it? What is mathematics? The study of patterns. What's the next one? 7 pi over 2. Do you guys know how to write an odd number? That you might have to be able to do. An even number is 2n. So if I have an even number, how would I get to an odd one? You could do 2n minus 1 or 2n plus 1, either way. I like the 2n plus 1. So this would be at 2n plus 1 times pi over 2. Because we're not going to have to do that, because they're going to give us a domain. So what's the domain? X belongs to the reals. What about the range? What are the y values between 1 and -1? Is this coming back now? Yes? No? Hopefully it's coming back. Oh, the tangent's always the fun one. The range is right here. The range of the outputs, or in this case, the y values. Did I get everything? So when you are asked to find the cosine of pi, which everybody struggles with it, but if you just draw the picture, it's really easy. By the way, these are the quadrants. This is the first quadrant, so I know the cosine's positive in the first quadrant. Then it becomes negative in the second quadrant. This is the third quadrant. It's still negative. In the fourth quadrant, it's positive again. I'll give you short things about that. We'll be reviewing trig in more detail. But these are the basic things you have to know cold. Okay, what about the tangent function? There are asymptotes here. What's the tangent of 0? Remember what this one looks like? Forget the numbers on there. I don't care about them. Like that. And then there's an asymptote here. Well, the inverse tangent's even crazier, but we'll deal with the inverses, but not today. That's enough. Where are these asymptotes? Do you remember what tangent is? Tangent of an angle is what? The sine of my angle over the cosine. When is the cosine what? Whenever the cosine is 0, because you can't divide by 0. So where's the cosine equal to 0? Pi over 2. That's where the asymptotes are. The period here is not 2 pi. So it's pi over 2, 3 pi over 2. What if I go backwards? What about this one? Negative pi over 2. And I don't care about writing it in the n forms. I don't care. You're going to have to, and I didn't think to review that, but you remember what the cosecant of a function is. No, x is not pi over 2. Sorry. You guys remember what cosecant is? Well, let's review that. I'm going to add a page. And we're going to draw a triangle. If I can find the triangles here. Oh, come on. Where are you? Oh. Okay. So here's my angle. Let's do all the trig functions. What's the sine of theta? Remember SOHCAHTOA? Yeah. So that's A over C. What's the cosine of theta? The adjacent over the hypotenuse, which is B over C. And the tangent of theta is A over B. What's another name for the ratio of A over B? It's rise over run. So it's slope. The tangent of your angle is the slope of the line. I don't know if you ever connected that. I don't think I did until I taught it. Okay, so now what is the cosecant of theta? For one. C over A. So how are cosecant and sine of theta related? They're reciprocals. Careful with inverses. 1 over the sine of theta. So what is the next word? What's the reciprocal of the cosine? Do you remember what that's called? Secant of theta. Okay, this is not going to work. Which is C over B. And the reciprocal of tangent is cotangent of theta, which is B over A. There aren't any other ratios in the triangle. That's it. There are 6, and that's all there are. And, you know, I have to do a Google search to find out why the Greeks named them sine, cosine, and tangent. I don't know, but they did. See, everybody, all the math you're learning, somebody's made up somewhere. It was Napier who called logarithms, and it had to do with ratios. So look up Napier-Bones. It has to do with that. I would prefer they had said inverse exponential because that makes sense. But somebody didn't do that. So we define things, and we have all agreed to do the same thing. So if I ask you for the square root of 9, there is only one answer. What's the answer? 3. That has a value of 3. If we solve x squared equals 9, and solve means to find numbers that make this true, and I'm going to bug you about that all year, because once we know what solve means, then it's a lot easier. But what numbers can you put in here that make this true? 3 and negative 3. Some of you are going to want to say the square root of 9 is negative 3. No, it's not. If it is, I've got a problem, because on my calculator, I'm going to get two different answers. And what do? Your calculator is a function machine. It has to be a function. Can I have only one output? Yes? Mm-mm. You're thinking of like squaring. So if I take negative 3 squared versus this, negative 3 squared, those have two different meanings. First off, I love math because it tells me what to do. If I just know how to read it and I know the rules, I know what to do. Because this one means a negative 3 times a negative 3, which is 9. This doesn't say that. This 2 is only working on the 3, not that negative side. This parentheses is what makes that 2 work on that negative. And one way to help you remember it is there is a number in front of there. It's 0. And if you remember order of operations, you have to do the squaring first and then subtract. So that gives you negative 9. Notice I didn't put any equal signs in here because I'm not solving an equation. I'm evaluating or simplifying. And actually, I have a nice list for my linear algebra students, and maybe I should give you the same list because I've already talked about function, but I'm not sure we know what it is. It's okay. A lot of math teachers don't either. Not here. They all know it here. What is a function? But your calculator is a function machine. Yesterday, I hit the jackpot. I put my money in for the pop machine, my $1.25, and Cokes just kept coming out of the machine. So what's wrong? The machine is not functioning. So I had 4 Cokes for my $1.25. You don't think that's hitting the jackpot? I think that's pretty good. Usually we get 2. This time they just kept coming out. So function is, that's why we say it's not functioning, because for every input, there is exactly 1. That means it has to exist. But there can't be any more than 1. So in math, when you use the word exactly, it has a very specific meaning. It means it has to happen, and you get 1. So sometimes when you put your money in the pop machine, nothing comes out. And you still will say it's not functioning. All these words do connect. This is not separate from an English class. So for every input, there is exactly 1 output. One of the teachers complained they had another couple students and they didn't have enough desks. They didn't have a function there either, because for every student, there has to be a desk. Depends on how you look at it. Okay, that's just some basic math. So now we remember the trig, right? You're going to have to remember these identities. Some people call them identities. That the cosecant is the reciprocal of the sine of theta. There's 2 other identities along here. See if I can remember the other one. Well, there's 3 you should know. Do you remember this one? Sine squared of x plus cosine squared of x? No? 1. So Pythagorean identity. Do you remember this one? This was the one you're not going to remember, probably. That one comes in handy all the time. It's 2 times, a lot of students want to make it 2 times the sine of x, but if you think about it for a moment, you realize it can't. This graph only goes up to 1, doesn't it? This graph goes up to 2, so they can't be equal times the cosine of x. And then I want the sine, not sine, cosine of 2x, which I believe, sorry, wrote it wrong. All right, cosine of 2x is the cosine squared of x minus the sine squared of x. All the other identities, those special identities, and I don't know how much you did in pre-calc last year, you don't have to know. Like the half angle and the double angle. So don't even worry about it. These are the only ones. These 3. Nope. Don't have to know it. Used to, but not anymore. And I think partly the reason is because we would just look it up, or it will be on my calculator. And I do have programs for, I got to find my calculator, but for the 83, 84, that has all the trig identities and everything you ever wanted. And I have an ACT program. So you might want that if you're going to take the ACT, which is coming up when? This Saturday? Okay, so if you have an 84, I'll try to find my programs and get them to you. Usually I have to find a student from last year. That always works. And I'll give that to you. You can use that. You cannot use a CAS calculator, though. Okay, back to where we were. So these are some special triangles. And you're saying, well, there's no triangle on number 7, and number 8 doesn't have a right triangle. You are right. But I'm going to make a triangle. So if this side is 1 and this side is 1, how long is that? Square root of 2. Guess what? I just drew an irrational number. That's exact. By the way, we just leave them that way. We leave them exact. So if this is 45 degrees, because remember from geometry that the diagonal bisects the angles in a square. What is that in radians? Do you guys remember? Pi over what? 4. Think of the 4 there. Just thought of that. Okay, so what is true about the sine of 45 degrees? It's what? 1 over the square root of 2. Now, that's a perfectly fine answer. But back of the book, that's not what you're going to see. Do you remember about rationalizing the denominator? They kind of beat it into you. It's not on the MCAs. I don't want a radical here. Now, the whole reason I don't want the radical here is because in my day and age, we had slide rules. I got a slide rule here somewhere. I'll have to dig it out and find it. You can't divide by an irrational number on a slide rule. That's the reason. Why do you have all those trig identities about the half angles and double angle formulas? Because we didn't have calculators. You had to manipulate everything and look things up in tables. Well, now we have calculators. I don't need all that. If I want to find the sine of 73 degrees, I just type it in. So it's kind of silly to memorize all those things. If I need it for calculus later on, and that's only if you're going to become a doctor, engineer, or a mathematician, that you would have to take more calculus. Then I'll deal with it then. So I'm going to rationalize this. And why is this going to work? What number am I multiplying by? Because we're going to do a lot of this. Square root of 2 over square root of 2 is 1. Okay, if you remember how to multiply radicals, that gives you the square root of 2. And the square root of 2 times the square root of 2 gives you just 2. And that's what you've learned. You've memorized it that way. That's fine. On the exam, 1 over the square root of 2 is just fine. 0.707. Why do I know that? I'm a physics major too, and we didn't have calculators till my junior year in college. So after a while, you got these special angles. You just knew what they were. So what's the cosine of 45 degrees? 1 over the square root of 2. What's the tangent of 45? So it's asking you the slope of a 45-degree angle. By the way, that's incredibly steep. You couldn't drive down a road that steep. If you want to, look at an 18% grade as we could to see how small that angle is. It's amazing. So when I do slopes, 1 is kind of the dividing point. If the slope is 2, it's going to be steeper than that. If the slope is a fraction, it won't be as steep as 1. 1 is when the height and this measurement here are the same. So those are easy. You have to memorize these. Now the 30, 60, 90s. And again, you're saying, well, I don't have a right triangle. But you know what? I'm going to get one. What's the angle in an equilateral triangle? 60. So what I'm going to do is draw the altitude here. That's straight. Okay. And that does what to the angle? Look at the picture. If you draw good pictures, you can assume. It does what? Bisects it. So this is 30, this is 60, and there's my 30, 60, 90 triangle. Now, I know you guys did the unit circle, but I also know you do not like fractions. So let's not use fractions. Let's make this 2. And if this side is 2, what else does this altitude do to that base? Bisects it, right? So that's 1. This So can you use Pythagorean's theorem to find the height? 1 squared plus h squared equals 2 squared. Some of you want to make it 1 plus h equals 2. And then my question for you is, then why did we ever make you square it? Because it's not the same. So you have to square it. So h squared is equal to 3, and h is equal to square root of 3. Now you should be able to do this algebra as quickly as I do. You may be rusty right now. I'm rusty. And there you go. So what I tell you to do is just draw the triangle at the beginning of the exam, put it on your paper, and it takes the stress away. Because now you're going to get in the middle of the exam and say, oh, I need to find the sine of 30 degrees. I can't remember what it is. Okay, what is the sine of 30 degrees? It's 1 over 2. Because I always get them mixed up. Even after my age, I still get them mixed up. What's the cosine of 30 degrees? Cosine is the adjacent, which is this, the altitude here, square root of 3 over 2. And what's the tangent of 30 degrees? Now remember, the angle's up here. So it's opposite over adjacent. So it's 1 over square root of 3, or, what's the other name for that? Square root of 3 over 3. So one of my former students calls me up. He's in his 30s now. He says, I have this tree. He calls it Mr. Scary. Because he thinks it's about 95 feet high. But that's the question. And I think he made this, I'm trying to remember, we'll make it 60 feet. And this, he said it's a 30-degree angle. I said, well, how did you measure that? How did you know it was a 30-degree angle? I'm not sure how he did it, but if you don't have surveying equipment, I don't see how you can measure the angle. So I said set up some similar triangles, find a place on the tree here, and then measure a distance here so that these lines would be parallel, then you could do it. Well, if you look at the tangent of 30 degrees, remember doing these problems? It's x over 60. Well, I know what that, so I did in my head. He said, well, get the calculator out. I said, I don't need to do that. I said, the height of that tree is going to be 60 times the tangent of 30 degrees. That's where I messed up. And so that was, what? Whoops, sorry. Then I needed a calculator. What's the tangent of 30 degrees? It's 1 over the square root of 3. We just had to divide that out. I forgot how big it was. But we realized that that wasn't right. His angle wasn't right. Because the tree was taller than that. He figured about 90 feet. And that didn't come out to that. I think this was 94, actually. So he's using that in his real life. He cuts down trees with using trig. So you can't get by without it. I haven't talked to him. I don't know if he got the tree down. So I haven't talked to him since. That was two days ago. Okay, so that's everything on that worksheet. Whew. So let me save this video. I want them separate, I think. Just got to find it. Don't do that. Oh, did I forget that? Oh, thank you. Yeah, I think you guys can figure out the other ones, right? Wait, hurt you to do that. I don't like this. I can't get to my... There we go.